Question: limit x tending to 0 log sin x upon cot x. Now cot 0 is 1 upon tan 0, that is nothing but, see, cot 0 is 1 upon tan 0, and this is nothing but 1 upon 0 is infinity, and log sin 0 is 0, sin 0 is log 0, and this is also infinity. So it is infinity by infinity form. ये infinity by infinity form है. You can rub all this. Rubbing all this. Now come to the point. Now using L'Hopital's rule, limit x tending to 0, 1 upon sin x, cos x, and this cot x can be written as minus cos x square x, cos x square x, which can be written as minus limit x tending to 0. This will become sin cube x. This will become sin cube x, sin square x, sorry, not sin cube but sin square x cos x upon, this becomes sin x. Now this sin x and this sin x will cancel out, and when we take the limit, it will become 0. It will become 0. Now again, let us do it. Question is, limit x tending to 0, x tending to infinity, sorry, x to the power of m upon e to the power of x. Now this is again infinity by infinity form. Now you have to use L'Hopital rule. Limit x tending to infinity, m minus 1, e to the power of x, infinity by infinity. Now carry on this up to m minus 1 terms. So this becomes m minus 1 and m minus 2 up to 3 to 1 upon e to the power of x. Now when you put infinity, e to the power of infinity is infinity. So this becomes m factorial upon some sort of infinity, and this is nothing but 0. This is nothing but 0. Now we will do another question. See, question: limit x tending to pi by 2 tan 3 pi by 2, sorry, not 3 pi by 2, it is tan 3x upon tan x. So this is, when you put pi by 2, this becomes infinity upon infinity. Now what you do is that differentiate. You use L'Hopital rule. X tending to pi by 2, 3 sec square 3x, tan 3x is sec square 3x, then into 3. Tan x is sec square x. So this becomes limit x tending to pi by 2. This becomes 3. If you take 3 out, this becomes cos square x upon cos square 3x. This becomes cos square x upon cos square 3x. Now you differentiate. Again, it becomes infinity by infinity form at pi by 2. Cos pi by 2 is 0. Sorry. This now becomes at cos pi by 2. This becomes cos 90 is. This now becomes 0 by 0. Again, use L'Hopital rule. Limit x tending to pi by 2. 2 cos x minus sin x. Again, 2 cos 3x. Then it is minus sin 3x. This is minus sin 3x. Wait. This is minus sin 3x and then into 3 by chain rule. So this becomes, see, this is limit x tending to pi by 2. This becomes sine 2x, and this becomes 3 sine 6x. Minus and this minus cancels out. Minus cancel out. Now at pi by 2, yes. Now that at pi by 2, this again becomes 0 by 0. Now again you differentiate. Again you differentiate using L'Hopital rule. Limit x tending to pi by 2, sine 2 cos 2x. Cos 2x into 2 rather. I should say like this. Wait a minute. I should say cos 2x into 2. Chain rule. This 2 will come here. 3 is already there. You put the 3 out. Sine 6x is cos 6x into 6. That 6 you keep here. Now you put pi by 2. Now you put pi by 2. Now this becomes, see, this becomes 1 by 9, 2, 3, and this 3 and this 3. 1 by 9. This becomes 1 by 9. 1 by 9. Limit x tending to pi by 2. Now you have cos 2x upon cos 6x. Now put the limit. This is 1 by 9 cos pi upon cos 3 pi. Now they are both, see, cos n pi is equal to minus 1 to the power of n. Cos pi, when n is 1, cos pi is minus 1. Cos 3 pi is minus 1 to the power of 3, and that is minus 1. So this is 1 by 3 minus 1 minus 1. This is nothing but 1 by 3.